This lightning talk will explain how OBP, object-based production, accelerates the intelligence cycle. My name is Jason Nichols. I'm SAIC's lab director. GEOINT capabilities, along with the transformative technologies of cloud, social media, and the Internet of Things, are evolving at a remarkably fast pace. The net effect is the generation of data at such an incredible rate, we constantly struggle to provide integrated, near real-time, actionable intelligence. The mission imperative was recently articulated by Sue Gordon at FedGIS in February, and she said, "Speed up the discovery, access to, processing, and visualization of geospatial content to support time-critical tactical requirements." Our role as technologists is to provide capability to meet that mission. Again from Ms. Gordon, we will provide cloud-based, scalable, responsive services for common use on many domains. This lightning talk will suggest that technology alone will not solve our dilemma, and that a new methodology is needed together with technology to meet the challenge. Object-based production is the core concept that has shown real promise. Where it's been applied, we've seen efficiency increases on several orders of magnitude.
To better understand OBP, we need to first examine the intel cycle, defined as task, collect, process, exploit, and disseminate, or TCPED. The intelligence cycle constitutes the building blocks that produce intelligence. And for the better part of the last century, TCPED has been executed within a given intelligence organization as a linear and set of stovepipe processes. So one organization will do the tasking, another will do the processing, another one the collection. And then we repeat this across 17 intelligence organizations. And then we add a bunch of technology over the last century, and we have this explosion of increase of data and information going into and coming out of all those stovepipe processes. It doesn't take a lot of thought to recognize that the linear and stovepipe nature of TCPED in the modern technology era is a problem.
Historically, we've tried to solve this TCPED problem with technology. Instead of changing the underlying process, we simply compensate for the flaws by using technology to give us the illusion that the problem is gone. In the early days of distributed computing, back to the 80s, we simply took the outputs of stovepipe processes and integrated them downstream of the production. And then we generated more data and information upstream because they, too, were using new technologies. So we added new technology downstream, integrated even more, and then more data came from all directions, and it repeats. So a question: how long do we keep thinking that new technology is going to address a process inefficiency? Rather, we should ask, what if the methodology is the problem? And until we solve that, we'll never be able to make significant progress by applying technology innovation.
Since the 1990s, the intelligence community has been trying to change TCPED. Some of you might recall horizontal integration. But what does it mean to actually change TCPED? In 2007, I was working a project to integrate a set of data. We were, in essence, about to repeat the process that Jason just described. As we looked at the data, though, what we began to recognize is that we could express all of it as something that exists, either physically or could be perceived in the real world around us. And because of that, we could describe specific ways in which these things looked, behaved, and interacted with other things. And that's when we had the epiphany. What if we used our technology to establish a shared set of objects of interest and have upstream organizations disseminate to those objects? And that essentially was the birth of OBP. Simply stated, we used objects to switch the responsibility for data and information integration to those who produce that data and information. And downstream, we access objects we're interested in and discover all that's known. Integration is a function of production or object-based production.
So let's consider the technology implications of what Jim just said. The concept of OBP is quite simple. It establishes a framework of interrelated objects, shares those objects across the entire IC, and directs process output toward them. As technologists, this means we must create a system of systems, which enables us to maintain object singularity. Our technology challenges are many, however. They include: how do we match information with objects? Is that matching process manual, automated, or both? Do we rehost the information in many places, or do we use pointers? How will 17 different organizations with relevant information need to publish while others subscribe? How do we know what's authoritative? And how do we prevent users from overwriting information from another agency? And finally, how do we integrate and leverage the existing investment made in tools and technologies to meet this new paradigm?
And as daunting as the technology challenge is, OBP means humans have to change the way they work. OBP means you have to think about your data and information in the context of the real world. How do we establish a rule set that ensures ensures everyone works consistently? Can everyone create objects or just a select few? Do we enforce a rigid ontology or develop a flexible one? OBP means both in an organizational sense and a technology sense that literally everything must change. In 2012, I had the opportunity to brief Principal Deputy DNI Stephanie O'Sullivan on OBP. At the end of the presentation, she asked me how long I thought it would take to implement it. I told her, you didn't get here overnight, ma'am, and you're not getting out overnight. This will take time.
So the good news is that we don't have to wait to get OBP benefits today. SAIC is advancing OBP through methods that improve how analysts develop, view, and share information using what's called an ontology. By applying techniques such as graph databases and graph-based visualizations, we enable our users to intuitively navigate through the interrelated information sets. As more information is added to the ontological framework, users will gain insight in the context of their interests. By delivering integrated data as a service, new analytics are now available. Analytics that monitor discrete objects or even groups of objects and report on that object behavior. SAIC uses those analytics to create new visualizations that allow an analyst to monitor or to be alerted to an anomaly that occurs against object behavior. This meets the mission challenge we mentioned earlier. Integrated, near real-time, actionable intelligence powered by OBP, process complemented by technology.
And OBP's impact extends to the intelligence enterprise itself. Not only can we see where information is populating the ontology, we can see where it is not, meaning we can literally see the collection gaps. We can also represent our tasking as objects and relate them to the intelligent production information and give us a sense of how our enterprise is arrayed against our priorities. Using objects as the foundational integration point for data and information, we can create an intelligence system that delivers integrated information as a service. And that's the promise of OBP, a significantly accelerated intel cycle.
So at this conference, SAIC will demonstrate an OBP processing environment, unclassified, looking at the enormously complex geopolitical South China Sea dispute. We'll show how analysis can be performed against this complex topic and enable stakeholders across the enterprise to share knowns, conversely, discover unknowns. Rather than showing an isolated demonstration of technology, we show a process environment complemented with technology that comes together to power the IC. Please visit us at 328 so we can continue this conversation. Thank you.
Thank you.